Okay, if you're watching this video, you're trying to get ready for your TEKS test. The first thing I'm going to talk about here is that the original review I gave you last week is due tomorrow. In order to know which problems you should do and any bonus questions or bonus things I wrote in the video on the worksheet, you're going to have to go watch the video in Google Classroom. I gave you a day to work on this in class, and you've had to do the rest of it outside of class. So again, this worksheet that says Review for Pre-Calculus Second Semester TEKS Test is due tomorrow, and you have to go watch Google Classroom video in order to know which problems that I assigned. On Friday, we worked our TEKS Test Review Practice 2, and I went through a whole worksheet and did every single problem with you. Today in class, I gave you TEKS Test Review Packet number 3, and this video is going to go over how to do these in case you had questions in class and didn't have a chance to ask me. So when you come in tomorrow for your test, the first thing you want to do is you want to make sure that your calculator is in degree mode. And you can just leave it in degree mode for the entire test. Okay, so I'm going to go ahead and put it in degree mode, and I'm going to put it aside. Number 1 says the hypotenuse of a right triangle. So I go draw a right triangle. Because it's a right triangle, the hypotenuse is the side opposite to that angle. And they tell me that that side opposite is 8. They tell me that one leg is 3 inches. It does not matter where you label the 3. You can label it over here on the left. You can label it at the bottom. It doesn't matter. They want you to find the approximate degree measure of each acute angle. So they want me to find this angle here. We'll call that A. And they want me to call this angle here. We'll call it B. So this is a right triangle. So therefore you could use SOHCAHTOA. But I'm going to use law of sines. And law of sines is this formula right up top. And it says if I have an angle and its opposite side, I can set it equal to another angle and its opposite side. So I do know that this is 90, and I know the opposite side is 8. So because I have an angle and an opposite side, I can use law of sines. So I'm going to have sine of 90 over the opposite side of 8 is equal to. Now I have 2 angles to find. I only know this side right here is 3. So the side that's opposite that angle is angle B. So sine of B over 3. From here, we're going to remember that we have to cross multiply the numbers. So I'm going to multiply 3 times sine of 90. And I'm going to get an answer in my calculator, and then I'm going to divide that by the number I didn't circle. So I'm going to divide it by 8. And then once I get that answer, I'm going to remember to second sign my answer. Whatever pops out is my angle. Okay, so here we go. I'm going to do 3 times sine of 90, hit enter, divided by 8. That was my decimal, and now I'm going to second sign, second answer. So my first angle, angle B, is 22. I'm just going to leave it as 22. I'm just going to round it to a whole number. To find the third angle, to find angle A, I'm going to remember that all triangles add up to 180 degrees. So if this angle is 90, and this one is 22, 90 plus 22 equals 112. So 180 minus 112 is going to give me my second angle of 68. So the 2 angles that I needed to find are 22 and 68. Number 2, in the triangle ABC. Notice they did not say it was a right triangle. So I just draw a regular triangle, and I'm going to label it A, B, and C. The side C measures 126. Side C is always opposite angle C. So if this is angle C, the side opposite is 126. It says side A measures 70. So if this is angle A, the opposite side is 70. And then they tell me that angle C measures 70 degrees. And they want me to find angle A. They want me to find this angle right here. Do I know an angle? Yes. And do I know the opposite side? Yes. Because I know the angle and the opposite side, I'm using law of sines again. So the angle I know is 70 degrees. The opposite side is 126. I'm looking for angle A. Angles go on top. And opposite angle A is the side 70. So we're going to do the exact same thing. I'm going to multiply these 2 together. So 70 times sine of 70 divided by the number I didn't circle. And then I have to remember once again to second sign. So here we go. I'm going to go type it in. So I'm going to have 70 times sine of 70, enter, divided by 126, and then I'm a second sign, second answer. And they only wanted that one angle, so angle A measures 31.5 or 32, or you can leave it as 31. It'll be multiple choice, so you'll pick the appropriate answer after looking at your answer choices. Number 3 is a navigation problem. Before I start doing number 3, I'm going to review our compass. So north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. So it says a jet flies on a course of 70 degrees. So I need to draw a compass. This is my compass. And 70 degrees is going to be in between 0 and 90. So this angle right here is 70. And I'm going to travel on this course for 300 miles. And then it tells me I'm going to turn. And the minute I turn, I'm doing a new compass. And I'm going to turn 140 degrees. Okay, so a couple things we have to remember is if I'm turning 140, that first quadrant is 90, plus how much more would give me 140? So plus 50 more. So I know this angle is 70, and this angle right here is 50, that wedge. So I need to find this angle in here. Because I know alternate interior angles, if this is 70, so is that little wedge. And because every quadrant adds up to 90, if this piece is 50, this is 40, so this entire angle is 110. And I also know that I traveled this direction for 180 miles. They want me to find the distance between where I started and where I am now. They want me to find this missing side right here. I'm going to call this C. You can call it A, you can call it B, you can call it whatever you want. But because I'm looking for this missing side, I'm going to call it C. I do have an angle. I have 110 degrees, but I do not know the opposite side. So I cannot use law of sines. This time, I'm going to go use law of cosines. And it says C squared equals, and I'm looking for C, A squared plus B squared. Either one of these can be A or B. I'll call this one A and this one B. So 300 squared plus 180 squared. Then the formula says minus 2 times 300 times 180 times cosine of 110. So I'm going to go type that in my calculator. So we're going to have 300 squared plus 180 squared minus 2 times 300 times 180 times cosine of 110. And we get this giant answer, but what you have to remember is that C squared. I want C. So I need to square root whatever answer I get before I'm done. So I'm going to second x squared, second answer. So it's 399 miles. Okay, so the first two problems I used law of sines because I had an angle and an opposite side. The last problem I used law of cosines because I had an angle but not the opposite side. So these formulas will be given to you on the test. You don't have to worry about memorizing these up top. Number 4 and 5 have to do with vectors. They ask you to find the magnitude. This formula will not be given on the test. You must know to find the magnitude, you're going to take a squared plus b squared and then square root it. And you also have to know that this is my a, the number in front of the I, and the 12 is the b because it's the number in front of the j. So to find the magnitude of k, and this is the notation that we use, you're going to take the square root of negative 5 squared, notice I put it in parentheses, plus 12 squared. Well, negative 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. And the square root of 169 is 13. Number 5 wants me to find the resultant of v minus w. So the first thing I have to do is I have to write both of these vectors in terms of I and j. So let's go do vector w first. If I'm going to write this in terms of I and j, remember I tells me how much I go left or right. So I'm going to always start at the dot and then go to the arrow. To get to the arrow, I'm going to go 2 to the right, so it's a positive 2i. Your b is going to tell you how much you moved up or down. So to get from this dot to this arrow, I went down 1, 2, 3, so it's negative 3j. So vector w was 2 to the right and 3 down, 2i minus 3j. To do vector v, I'm going to do the same approach. going to put a dot right here where the arrow is not. To get to the arrow, I'm going to go 1 left, so negative 1i. You don't have to put the 1, you could just put negative I. And then I'm going to go down 1, 2, 3, 4, and because I went down, it's a minus 4j. So now that I've written my two vectors, I can go subtract them. They want me to write vector v first, so negative I minus 4j minus vector w, 2i minus 3j. And now I'm just going to subtract the i's with the i's and the j's with the j's. So negative 1 minus 2 would give me negative 3, and they're still i's. Negative 4 minus a negative 3. Remember, a double negative changes to a plus. So negative 4 plus 3 is negative 1j. Number 6 wants me to sketch a picture of the graph, and you'll notice this equation does not say y equals, it says r equals. So the minute you see that, you're going to have to remember not only do you need to be in degree mode, but you also need to be in polar. So I'm going to go back to mode. I'm already in degree, but I'm going to come down here to polar and hit enter. Now when I hit y equals, they all say r. You also need to go to your window, and because I'm in degrees, I want to go from 0 to 360 because there are 360 degrees in my circle, and I'm going to count by 5s because 5 divides into 360 evenly. So now I'm going to go in, I'm going to type in 2 sine 4 theta, and your theta is right here with your x, right there. So you just press the x button and theta pops up, and then you're going to hit graph. I'm going to see this itty bitty graph, and so if that's good enough for you, that's fine. I'm going to zoom in. So I'm going to go to zoom in, hit 2, and hit enter 1 time. And now I can tell that each one of my petals is about 2 units long, and I have 2 petals in each quadrant. So 1, 2, and it looks like they're about 2 long in each quadrant. It doesn't have to be perfect, just good enough so that you can look at a graph and pick the right picture. All right, number 7 wants me to graph the following polar coordinates. And I'm going to remember when I graph polar coordinates, the first number is going to represent the r, which is the radius, and your second number represents your theta. You'll notice that my theta in this particular problem are all in radians, and they're all the denominators of 4. So the first thing I'm going to go do is I'm going to go draw my circle, and I'm going to go label where my 4's are. So this is pi over 4. This is 3 pi over 4, 5 pi over 4, and 7 pi over 4. The next thing I'm going to notice is that all these numbers out front, all the radius are 2. So I need 2 unit circles. So there's my radius 1, there's my radius 2. So when you graph in polar, you start with the theta. So this says start with pi over 4. So I'm going to be on this line right here. And it says I'm going to go a positive radius. That means I'm going to go towards that number pi over 4. So I go start at the bullseye, and I go 1 circle in, 2 circles in. There is point A. To do point B, they want me to go to where negative 7 pi over 4 is. Well, positive 7 pi over 4 is 1, 2, 3, 4 pi over 4 is this direction. So if I need a negative 7 pi over 4, I have to go 4 pi over 4 is the other way. So 1, 2, 3, 4. So pi over 4 is also negative 7 pi over 4. And it says my radius is negative 2. The negative just tells me the direction. So instead of going towards the A, I'm going to go away from the A. And I'm going to label that B. The next one they want me to go to is negative 5 pi over 4. Well, positive 5 pi over 4 is 1, 2, 3 pi over 4s, that to the left. Now I'm going to go 3 pi over 4s the other way. So 1, 2, 3. So this is also negative 5 pi over 4. It's a positive 2, so I'm going to go 2 towards the angle that I just wrote, 1, 2. And there's point C. Letter D wants me to go to negative pi over 4. Positive pi over 4 was 1 pi over 4 up. So negative pi over 4 is going to be 1 pi over 4 down. So here's my negative pi over 4. And they want me to go negative 2, so they want me to go 2 away. So they want me to go 1, 2. They want me to go this direction right here. So C and D are the same point. A and B are the oddballs. Number 8 says sketch the picture, but now both these equations are back at y equals. So you're going to have to remember to go back to your mode, you can stay in degree, but you need to go back to function. So I'm going to go hit mode. I'm going to stay in degree, but I'm going to go back to function mode so that when I hit y equals, I'm back where I want to be. And I'm simply just going to go type this in, log of negative x, and I'm going to hit graph, and then I'm going to go sketch my picture. It's a curve that approaches the asymptote right here, the y-axis. Okay, the next one, it's the same concept. It says y equals, and it says negative log of x. And I'm going to go hit graph, and then I'm going to draw that curve. It's still going to have the same asymptote on the y-axis, and it's going to go down like that. So just being able to type in your calculator and pick the right picture. On number 9, they're talking about population of bacteria, and it's a growth or decay problem. This problem says it's going to triple. Because it's going to triple, I'm going to have a growth rate of 3. My initial population is 10,000, and they want me to write the equation that would represent the population after X hours. So when you're writing these, you always start with your initial population, which was 10,000. And then you're going to multiply it by whatever your growth rate is. If it's double, you pick 2. If it's triple, you pick 3. If it's a half-life, you'd write in 1/2. Well, this is a triple, so I write in 3. And we're going to raise it to the X hours. 10 and 11 are both log problems. On number 10, they want me to simplify this problem. So we need to remember that every time we're simplifying, you see a plus sign, we're going to rewrite it as multiplication. When I see a subtraction sign, I'm going to remember to rewrite it as division. And when you have a number that you multiplied out front by, you're going to change it to an exponent. So they want me to take these 3 logs, 1, 2, 3, and change it into one log expression. So the word log should only be written one time. So it says that I'm going to add log A to 2 times log B. Because it said to add, I'm really going to multiply. And because there's a 2 out front, it's going to be B squared. So the plus sign made it multiplication, the 2 out front made the b squared. The subtraction sign tells me to divide by c. Notice the word log is written out front one time, and then I have ab squared divided by c. Number 11 is a solving for x problem. Looks like it's going to be solving exponentially. If it was exponential, you try to get like bases. But 4 to the first power is 4, 4 squared is 16, 4 to the third, that's not 26. So there's no way to get like bases. When you can't get like bases, you're going to take the log of both sides. And by taking the log of both sides, I can now do this property over here backwards. I can take the exponent and bring it out front. So x times log of 4 equals log of 26. And the opposite of multiplication is division. So x is going to equal the log of 26 divided by the log of 4. And we're going to stop right there. That's it. On the back, these next 3 problems are all about sequences and series and finding the number of terms or finding a sum. In order to be successful, you're going to have to know whether it's arithmetic or geometric. It's arithmetic if you add the same number over and over, and it's going to have what we call a common difference. It's geometric if you multiply by the same number over and over, and it's going to have a common ratio called r. So on number 12, they want me to find the sum, and these formulas right here will be written on your test. Because it's a sum, I know it's going to be one of these equations that has an s in it. And they tell me for the first 15 terms. That means I also need an equation that has an n in it. So now I know it's only one of these two. This one doesn't have an n. So once I know if it's geometric or arithmetic, then I can pick which equation I need. So I'm trying to decide how am I getting from 4 to 8 to 16. And some people will go, oh, you're adding 4, because 4 plus 4 is 8. But is 8 plus 4 16? No, it's not. Well, are we multiplying? 4 times 2 is 8, and 8 times 2 is 16. So yes, this is geometric, and we're multiplying by 2, so my r is 2. Because I have an r, it means I'm going to use this equation right here. So remember, my n is 15, and then it says a. A is going to be whatever the first number is in your series or sequence, which is 4. And then it says times 1 minus r, my r is 2, raised to the n is 15, over 1 minus r. And then you're going to go type it in your calculator. Now when I type it in my calculator, I type in the fraction first to get an answer and then multiply it by 4. Because there's more than one thing going on in the numerator and the denominator, you have to remember to put parentheses when you type it in. So 1 minus 2 raised to the 15th divided by 1 minus 2. And I know some of y'all could just go, oh, that's negative 1. And then I have to take that answer and multiply it by the 4 out front. So 131,068 is the sum. Okay, the next problem says an auditorium has 14 seats in the first row, 18 seats in this next row, and 22 seats in the third row. And they want to know how many seats will be in the 31st row. So again, they want to know how many, but this time they don't want to know the sum, they want to know how many. So it's going to be one of these two equations over here. I have to decide, is it arithmetic or is it geometric? So how am I getting from 14 to 18 to 22? Well, to get from 14 to 18, I could add 4. And is 18 plus 4 22? 18, 19, 20, 21, 22? Yes, it is. So this is arithmetic. And my common difference is 4, because that's what I'm adding over and over. Because it's arithmetic and I have a common difference, I'm going to use this equation up top. N is going to be the row that they're asking me about. So A31 equals A. Remember, A is the first one. 14 plus N, we said N was 31, minus 1 times D, and we said D was 4. And then we're just going to go type it in our calculator. So 14 plus 31 minus 1 times 4. So there will be 134 seats in that row. All right, the next one, number 14, they give me a series. They want me to write out a series in sigma notation. Remember, the number on bottom, right here at the bottom, tells you where to start your series, and the number on top tells you where to stop. So I'm going to start with 1, I'm going to stop at 4. And for every k, I'm going to cube it. So 1 to the third, 2 to the third, 3 to the third, 4 to the third, and stop. Now I simply go evaluate. 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, and 4 to the third is 64. And you're done. Okay. On number 15, it's all about this graph over here. And a couple of things we need to remember is if you have an even function and it's positive, it looks like this, both arms up. If it's negative, both arms down. So by looking at this, I can tell it's going to be a positive and it's going to be even. If you have an odd function and it's positive, one arm goes up, the right one, and the left arm goes down. If it was negative, the right arm goes down, and the left arm goes up. So you're going to need to know that in order to answer B. All right, so the first thing it actually asks is, what is the solution to the inequality where f of x is greater than or equal to 0? That means, where am I above the x-axis? And I'm above the x-axis in the intervals that I highlighted. So this interval over here, remember, you do intervals, you're talking about your x's, from negative infinity, because there's an arrow, all the way until I get to positive 1, and 1's included. And then I pick up again when I get over here, 1, 2, 3, 4. When I get to the 4, I pick it up again, and it goes on forever. So everywhere that I was above the x. B says, does this function have a positive or negative leading coefficient? Well, I know it's an even function because both arms went up, and because they both went up, it's positive. C asks me some questions about the roots. Remember, your roots are your x-intercepts, and it's asking about the x-intercept at -3, and it's asking about the x-intercept at 1. And they're asking me, does it have an even or an odd multiplicity? So let's review that. If you have an even multiplicity, you simply touch the x. If you have an odd multiplicity, you cross over the x. So right here where x equals -3, did I actually go through the x-axis or just touch it? Well, I just touched it, which means it's an even multiplicity. But over here at +1, I actually went through the x-axis. I crossed over. So at +1, it's an odd multiplicity. So when you go to write the factors for this, you need as many factors as you have x-intercepts, and I have 3 of them. At -3, I touch. At 1, I cross. And at 4, I cross. So when you write your factors, you need as many factors as you have x-intercepts. I have 3. You always write the opposites inside. So I have x plus 3, and because it touched, I need an even power. I'll choose 2. I have a positive 1, so I write minus 1. Because it crossed over, I need an odd power. I'll choose 1. You don't have to write that. I'm just showing you. The next one is at 4, so I write minus 4. I crossed over again, so I need another odd power. I'll choose 1. Letter E says, is this function always increasing? Well, if I start at the left, I'm immediately going which way? I'm going down. So the answer is no. I'm not always increasing. On 16 and 17, you're going to do these right in your calculator. 16 wants to know what are the roots. That just means where does it touch the x-axis. So I go type it in. 4x raised to the third, arrow out, minus 6x squared minus 16x minus 6. And I'm going to go hit graph. And it looks like I need to zoom back out, so I'm going to zoom standard, back to my standard window. And I'm just going to write down a blank for however many times it touches the x. And it looks like it touches the x. Uh-oh, did I type it in right? Negative, it's 4x squared minus, oops, I did not type it in right. I put a time sign here. This should be a minus 16x. Okay, so how many times am I touching the x-axis? It looks like I'm touching 1, 2, 3, so I need 3 possible answers. And if I'm touching the x, it means my y actually equals 0. So I have a 0 at negative 1. I have a 0 at positive 3. So let's go back. Oh, it looks like I have a 0 somewhere right in between 0 and 1, which let's just guess. Let's say that's negative 0.5 or negative 1/2. That actually works. Remember, your test is multiple choice, so if you can't tell what the fraction is, just hit your second window, type in one of the answer choices, go back and see, does it give me 0? 17 wants you to complete a behavior statement. It's really just testing whether or not you know what the negative infinity and the positive infinity means. So again, we're going to use our calculator. I'm going to go type this in, negative x raised to the 5th, arrow out, plus 2x raised to the 4th, arrow out, minus 6x squared plus x. I'm going to go look up my picture. Okay, so this statement down here says, as x approaches negative infinity, that means as x goes left, f of x, which is y, goes which way? So as I go to the left, I go up. Because I go up, I write positive infinity. Then it says, as x approaches positive infinity, so as x goes right, f of x, which means y, so as I move to the right, I go down. Because I'm going down, I write negative infinity. Number 18 wants to know which of the following has a removable discontinuity. That phrase simply means, does it have a hole in the graph? You will know it has a hole in the graph if something cancels. So if I have exactly the same number on top as I have on bottom, something will cancel. So these are not exactly the same, so this is a no. This one I have x plus 5 and x plus 5. Those are exactly the same, so they would cancel. So this would, yes, have a hole. X minus 2, x plus 2. No, they're not exactly the same. So far, just one. X plus 2, x plus 2. Yes, this one would also have a hole. So you're going to have a removable discontinuity if the same numbers cancel on top and bottom. Number 19 is reviewing 1 over x graphs. So you'll notice that this graph right here, it moved 1, 2, 3 left, and it moved up 1. So because it went 3 left, on the bottom, I'm going to have x plus 3. We always write the opposite when I go left and right, and I went up 1. This graph over here is also a 1 over x graph, but this time I moved right 5 and up 2. So y equals, because I moved to the right, I write x minus 5, and I moved up 2. Okay, guys, so let's recap one more time. So what's due tomorrow in class? Tomorrow in class, this worksheet is due, the original one I gave you. You need to go watch the video in Google Classroom and fill in everything I told you to. Turn it in when you walk in the door. Yesterday in class, we did this review. Look over it if you want to. And then today in class, we did the one that I just did with you. I am not taking either of these two up. The only one that's for a grade is this one right here that you had to do on your own. Okay, I hope that cleared up any questions you have. If you're missing any worksheets, go on to Google Classroom. This worksheet's on there for you to print out, and the video's there. All right, good luck.